Welcome to this interactive lab simulation for the lab implementing identity services and group policy. To navigate in this lab, in this first task, you'll deploy ADDS on a new Windows Server core server. On the Seattle Admin 1 server, from Server Manager, select All Servers. Open Windows PowerShell and select Run as Administrator. Use the Install Windows feature commandlet to install the ADDS role on Seattle Server 1. Use the Get Windows feature commandlet to verify the installation. Ensure the checkboxes are selected for Active Directory domain services, remote. In the next task, you'll prepare the ADDS installation and promote a remote server. Return to Server Manager. From the Manage menu, select Add Servers. Select Find Now, and then add Seattle Server 1 as a managed server. Next, select the Notifications flag and promote Seattle Server 1 to a domain controller for the existing domain. Click Change. Provide the credentials to perform this operation. Retain the selection. Enter the Directory Services Restore Mode, or DSRM, password. Proceed through the wizard, retaining the default selections. On the Review option, in Notepad, edit the generated Windows PowerShell script as shown. First, delete the comment lines. Next, remove the Import Module line. Next, remove the accent marks at the end of each line. Next, remove the line breaks. Now that the command and all the parameters are on one line, copy the command. Close Notepad. Cancel out of the wizard. Switch to Windows PowerShell, and then at the command prompt, enter the command as shown. Paste the copied command between the braces and run the resulting command to start the installation. Provide the administrator credentials. Specify and then confirm the Safe Mode Administrator password. After Seattle Server 1 restarts, on Seattle Admin 1, switch to Server Manager. Select the ADDS. Note that Seattle Server 1 has been added as a domain controller and that the warning notification has disappeared. In the next task, you'll manage objects in ADDS. Switch to the Windows PowerShell console. To create an organizational unit, or OU, called Seattle, run the command as shown. To create a user account for Ty Carlson in the Seattle OU, run the command as shown. Next, set the user's password. Next, enable the user account. Next, create a domain global group named Seattle Branch Users. Now add the Ty user account to the newly created group. Confirm that the user is in the group. Finally, add the user to the local administrators group. This exercise is now complete. Click the screen to continue. In this next exercise, you'll configure group policy. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create and edit a GPO. On Seattle Admin 1, return to Server Manager. From the Tools menu, open the Group Policy Management console. In the Group Policy Objects container, create a GPO named Contoso Standards. Open the Contoso Standards GPO in the Group Policy. Navigate the folder structure to the System folder. Select the Prevent Access to Registry Editing Tools policy setting and then enable it. Next, navigate to the Control Panel folder and select the subfolder titled Personalization. Select the Screensaver Timeout policy and then enable it. Configure the Screensaver Timeout policy to 600 seconds. Select the Password Protect the Screensaver policy setting and then enable it. Close the Group Policy Management Editor window. In the next task, you'll link the GPO. Select the contoso.com domain and then follow the prompts to link the Contoso Standards GPO. In the next task, you'll review the effects of the GPO's settings. On Seattle Admin 1, navigate to Control Panel. Click System and Security. Under Windows Defender Firewall, select Allow an app through Windows Firewall. Scroll down. Enable Remote Event Log Management domain traffic. Sign out. Now sign in to the TIE user account. Navigate to Control Panel and then attempt to change the screensaver wait time and resume settings. Verify that Group Policy blocks these actions. Sign out. Sign in to the administrator account. In the next task, you'll create and link the required GPOs. From Server Manager, click the Tools menu and select Group Policy Management. In the Group Policy Management console, create a new GPO named Seattle Application Override that is linked to the Seattle OU. Select Seattle Application Override and select Edit from the right-click menu. Navigate to the Screensaver Timeout Policy setting. Disable the policy setting and then close the Group Policy Management Editor. In the next task, you'll verify the order of precedence. Select the Group Policy Inheritance tab. Review the order of precedence. Next, in the Group Policy Management console tree, expand the Seattle OU. In the next task, you'll configure the scope of a GPO with security filtering. Select the Seattle Application Override GPO. Notice that in the Security Filtering section, the GPO applies by default to all authenticated users. Select Authenticated Users and then click Remove. Confirm the removal. Next, add the Seattle Branch Users Group and the Seattle Admin 1 computer account. In the next task, you'll verify the application of settings. In Group Policy Management, in the navigation pane, select Group Policy Modeling. Launch the Group Policy Modeling wizard. Click Next. Set the target user to the TIE user account. Set the target computer to the Seattle Admin 1 computer. Step through the remaining pages of the wizard, review the default settings without modifying them, and complete the wizard, which will generate a report containing its outcome. After the report is created, in the Details pane, select the Details tab and then select Show All. Notice that the screensaver timeout settings are obtained from the Seattle Application Override GPO. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab implementing integration between ADDS and Azure AD. To navigate this interactive, in this lab, you'll complete the exercises listed on the screen. In this first exercise, you'll prepare Azure AD for ADDS integration. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create a custom domain name in Azure. On Seattle Admin 1, open Microsoft Edge to the Azure portal page. Signed into Azure as an administrator, browse to Azure Active Directory. Scroll down and select Custom Domain Names. Click Add Custom Domain and then add contoso.com. Review the DNS record types that you would use to verify the domain, and then close the pane without verifying the domain name. In the next task, you'll create a user with the Global Administrator role. In the left pane, select Users. Follow the prompts to create the new user. Click User and then assign the role of Global Administrator. Click Create. Refresh the page. In the next task, you'll change the password for the user with the Global Administrator role. Sign out from the Azure portal and sign in with the newly created user account. When prompted, change the password. This exercise is now complete. Click the screen to continue. In this next exercise, you'll prepare the on-premises ADDS for Azure AD integration. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install ID Fix. On Seattle Admin 1, navigate to the GitHub page for the ID Fix tool. Scroll down to the Click Once Launch section, and then select Launch. Open the setup.exe file and install ID Fix. Review the IDFix privacy. In the next task, you'll run IDFix. In the IDFix window, select Query. Click Yes. Review the objects from the on-premises Active Directory and notice the attribute and error columns. In this scenario, the value of display name for Contoso admin is blank, and the tool's recommended new value appears in the Update column. To implement, click Yes. Click Query and close the IDFix tool. This exercise is now complete. Click the screen to continue. In this next exercise, you'll implement the integration by downloading, installing, and configuring Azure AD Connect on Seattle Admin 1. Follow the prompts to complete the one task in this exercise. In this task, you'll install and configure Azure AD Connect. On Seattle Admin 1, navigate to the Azure Active Directory page. Scroll down and select Azure AD Connect. Click Download Azure AD Connect. Download the Azure AD Connect installation binaries and then start the installation. Agree to the terms and continue. Select the option to use Express settings. On the Connect to Azure AD page, enter the credentials of the Azure AD Global Administrator user account you created in Exercise 1. On the Connect to ADDS page, enter Active Directory Domain Services Enterprise Administrator credentials. On the Azure AD Sign-In Configuration page, notice the new domain you added in the list of Active Directory UPN suffixes. Select the checkbox labeled Continue without matching all UPN suffix. Click Next. Review the list of actions and then start the installation. This exercise is now complete. Click the screen to continue. In this next exercise, you'll verify integration between ADDS and Azure AD. Follow the prompts to complete the tasks in this exercise. In this first task, you'll verify synchronization in the Azure portal. On Seattle Admin 1, return to the Azure AD Connect page and refresh it. Review the information under Provision from Active Directory. Next, navigate to the Users page. Observe the list of users synced from Active Directory. Close the page. Next, navigate to the Groups page. Review the list of groups synced from Active Directory. In the next task, you'll verify synchronization in the Synchronization Service Manager. From the Start menu, navigate to Synchronization Service. In the Synchronization Service Manager window, under the Operations tab, review the tasks that were performed to sync the Active Directory objects. Next, select the Connectors tab. Note the two connectors and close the window. In this next task, you'll update a user account and create a new one in Active Directory. Open Server Manager. On the Tools menu, select Active Directory Users and Computers. Expand the Sales Organizational Unit, or OU, and then open the properties for Sumesh Rajan. Select the Organization tab. In the Job Title text box, enter Manager, and then select OK. In the next task, you'll create a new user account in the Sales OU. Click Finish. In this next task, you'll sync the changes to Azure AD. Start Windows PowerShell as an administrator. In the Windows PowerShell console, run the command as shown to trigger synchronization. In this next task, you'll verify the changes in Azure AD. Switch to the Microsoft Edge window displaying the Azure Active Directory page. Navigate to the Users page. Search for and select the user, Sumesh. Open the Properties tab. Scroll down and verify that the job title attribute has been synced from Active Directory. Close the page. Next, search for and select the user, Jordan. Open the Properties tab and then review the attributes of the user. When you're ready, close the page. This exercise is now complete. Click the screen to continue. In this next task, you'll implement Azure AD integration features in ADDS. Follow the prompts to complete the tasks in this exercise. In this first task, you'll enable self-service password reset in Azure. To do this, you'll need Azure AD Premium P2. Scroll down the left pane of the Azure Active Directory page and select Licenses. Next, select All Products. Click Try Buy, and then activate the free trial of Azure AD Premium P2. Assign an Azure AD Premium P2 license to the Azure AD Global Administrator user account you created in Exercise 1. Close the page. Next, scroll down the left pane and select Password Reset. On the Password Reset page, note that you can select the scope of users to which to apply the configuration. For now, don't enable this feature. In the next task, you'll enable Password Writeback in Azure AD Connect. To begin, navigate to Azure AD Connect. Click Configure. Select Customize Synchronization Options and then click Next. Enter the username and password of the Azure AD Global Administrator user account. Continue through the steps. On the Optional Features page, select Password Writeback. Review the list of actions to be performed, and then select Configure. When configuration completes, click Exit. In this next task, you'll enable pass-through authentication in Azure AD Connect. Navigate back to the Azure AD Connect page. Click Configure. On the Additional Tasks page, select Change User Sign-In. Click Next. enter the credentials of the Azure AD Global Administrator user account. On the User Sign-In page, select Pass-Through Authentication. Verify that the Enable Single Sign-On checkbox is selected. Click Next. On the Enable Single Sign-On page, select Enter Credentials. In the Forest Credentials dialog box, authenticate using Domain Administrator credentials. Click Next. And then select Configure. When configuration completes, click Exit. Next, return to Azure AD Connect. Scroll down. Sign in, review the information, and then select Seamless Single Sign-On. Verify the on-premises domain name, and then close the page. Next, under User Sign-In, select Pass-Through Authentication. Note the authentication agent server information. In the next task, you'll install and register the Azure AD Password Protection Proxy Service and DC Agent. Browse to the Microsoft Downloads page for Azure AD Password Protection for Windows Server Active Directory. Click Download. Select both files and then click Next. Click Allow. Next, open Windows PowerShell. Run the command as shown to remove the zone.identifier alternate data stream, indicating that files have been downloaded from the Internet. Next, create a C drive temp directory on Seattle Server 1, and then copy the Azure AD Password Protection Proxy Setup installer to that directory and invoke the installation. Next, create a C drive temp directory on Seattle Domain Controller 1, and then copy the Azure AD Password Protection DC Agent Setup installer to that directory and invoke the installation. Next, restart the domain controller. Next, validate that the installations resulted in the creation of services necessary to implement Azure AD Password Protection. Now start a PowerShell remoting session to Seattle Server 1. Within the PowerShell remoting session, register the proxy service with Active Directory. Open Microsoft Edge and authenticate by using the Azure AD Global Administrator user account. Return to Windows PowerShell. Exit the PowerShell remoting session to Seattle Server 1. Next, start a PowerShell remoting session to Seattle Domain Controller 1. Within the PowerShell remoting session, register the forest with Active Directory. Next, authenticate using the Azure AD Global Administrator user account. Exit the PowerShell remoting session. Go back to the Azure Active Directory page. In the next task, you'll enable password protection in Azure. Scroll down to Security and then select it. In the left pane, select Authentication Methods. Select Password Protection. To enforce a custom list, click Yes. In the text box, enter a banned password list relevant to the organization. Verify that the Enable Password Protection on Windows Server Active Directory setting is enabled and that the mode is set to Audit. Save your changes. This exercise is now complete. Click the screen to continue. In this next exercise, you'll clean up by uninstalling Azure AD Connect and disabling synchronization with Azure. In the first task, you'll uninstall Azure AD Connect. On Seattle Admin 1, open Control Panel. Select Uninstall a Program and then uninstall Microsoft Azure AD Connect. Next, click the Azure AD. Click Remove. When all the components are successfully uninstalled, click Exit. In the next task, you'll disable directory synchronization in Azure. Open Windows PowerShell. Run the command as shown to install the Microsoft Online module for Azure AD. Answer Yes. Answer Yes to all by entering A. Next, run the command as shown to provide credentials to Azure. Enter the credentials of the user account that was created in Exercise 1. Next, connect to Azure. Finally, disable directory synchronization in Azure. Confirm that you want to continue with this operation. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Managing Windows Server. To navigate this in this lab, you'll complete the exercise listed on your screen. In this exercise, you will implement and use remote administration. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install Windows Admin Center. On Seattle Admin 1, start Windows PowerShell as an administrator. From the Windows PowerShell console, run the command as shown to download the latest version of Windows Admin Center. Next, enter the command as shown to install Windows Admin Center. In this next task, you'll add servers for remote administration. On Seattle Admin 1, start Microsoft Edge and then go to https://seattleadmin1.contoso.com. Sign in with administrator credentials. Click the question mark in the upper right corner to learn about and get help with Windows Admin Center. Select What's New and scroll down to see the latest release notes. Go back and close the pane to return to the All Connections page. Note that the page includes the seattleadmin1.contoso.com entry. Click Add and then add a connection to seattledc1.contoso.com. Select the option to use another account for this connection and then provide administrator credentials. In this next task, you'll configure Windows Admin Center extensions. In the upper right corner, select the Settings icon. Select Extensions and then review the available extensions. Select and then install the Security Preview extension. Verify that the list of installed extensions includes the DNS Preview extension. Next, click the Settings drop-down arrow and select Server Manager. Connect to seattledc1.contoso.com. Sign in with administrator credentials. Next, connect to the DNS server on seattledc1.contoso.com and install the DNS PowerShell tools. Select the contoso.com. In the next task, you'll verify remote administration. Continuing from the same screen, navigate to the Overview page. Note that the page displays basic server information and performance monitoring. Next, navigate to Roles and Features. Scroll down. Select the Telnet client and install it. Next, select Settings and enable Remote Desktop. Next, connect via Remote Desktop to this computer. Disconnect from the Remote Desktop connection and close the browser window. In the next task, you'll administer servers with Remote PowerShell. In the Windows PowerShell console, run the command as shown to start a PowerShell remoting session to Seattle Domain Controller 1. Next, run the command as shown to display the status of the Application Identity Service. Verify that the service is currently stopped. Next, run the command to start the Application Identity Service. Finally, run the command as shown to display the status. Verify that the service is currently running. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab using Windows Admin Center in hybrid scenarios. To navigate this interactive lab simulation, follow the prompt. The objective for this lab is to perform the exercises listed on your screen. In this exercise, you will provision Azure VMs running Windows Server. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create an Azure resource group by using an Azure Resource Manager template. On Seattle Admin 1, browse to the Azure portal. Open Cloud Shell. Upload the applicable Azure Resource Manager template file to the Cloud Shell home directory. From the Cloud Shell pane, run the commands as shown to create a resource group. In the next task, you'll create an Azure VM by using an Azure Resource Manager template. From Cloud Shell, upload the applicable Azure Resource Manager template and the corresponding Azure Resource Manager parameter file. Run the command as shown to deploy an Azure VM running Windows Server. Close the Cloud Shell pane. In the Azure portal, navigate to Virtual Networks. Select the virtual network. Click Subnets. Add a gateway subnet to the virtual network. Change the subnet address range as shown. This exercise is now complete. Click the screen to continue. In this next exercise, you'll implement hybrid connectivity by using the Azure Network Adapter. Follow the prompts to complete the tasks in this exercise. In this first task, you'll register Windows Admin Center with Azure Shell as an administrator. Run the commands as shown to download and install the latest version of Windows Admin Center. Start Microsoft Edge and connect to the local instance of Windows Admin Center. From the Windows Admin Center page, attempt to add an Azure Network Adapter. When prompted, register Windows Admin Center to the Azure subscription you used in the previous exercise. Close the Browser tab. Follow the prompts to complete the one-time registration. Sign in. Accept the permissions. In the next task, you'll create an Azure Network Adapter. Continuing in Windows Admin Center, navigate to Server Manager. Connect to the server. Attempt to create an Azure Network Adapter again using the settings shown. Next, switch to the Microsoft Edge window displaying the Azure portal and verify that a new virtual network gateway was provisioned. This exercise is now complete. Click the screen to continue. In this next exercise, you'll deploy Windows Admin Center Gateway in Azure. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install Windows Admin Center Gateway in Azure. On Seattle Admin 1, start a PowerShell session in the Cloud Shell pane. Upload the Windows Admin Center provisioning script as shown. Next, run the command as shown to enable compatibility for the Azure Resource Manager PowerShell commandlets that are used by the Windows Admin Center provisioning script. Set the values of variables necessary to run the Windows Admin Center provisioning script. Next, disable certificate verification for PowerShell remoting. Answer yes to all by entering the letter A. Next, run the command to launch the provisioning script. Provide a name and password for the local administrator account. Verify that the script completed successfully, and note the final message providing the URL containing the fully qualified name of the Azure VM that hosts the Windows Admin Center installation. Close the Cloud Shell pane. In the next task, you'll review results of the script provisioning. In the Azure portal, browse to the page of the resource group. On the overview page for the resource group, review the list of resources. Select the Azure VM running Windows Admin Center. Click Networking. On the Inbound Port Rules tab, note entries allowing connectivity on TCP ports 5986 and 443. This exercise is now complete. Click the screen to continue. In this next exercise, you'll verify the functionality of the Windows Admin Center Gateway in Azure. Follow the prompts to complete the tasks in this exercise. In this first task, you'll connect to the Windows Admin Center Gateway running in Azure VM. On Seattle Admin 1, connect to the Windows Admin Center Gateway running in the Azure VM you identified in the previous exercise. Select Advanced and then sign in using the credentials for the local administrator account. On the All Connections pane of the Windows Admin Center, select the server link. Examine the Overview pane of Windows Admin Center. In the next task, you'll enable PowerShell remoting on an Azure VM. Next, browse to the Virtual Machines page. Select the virtual machine with the suffix VM0. Scroll down and select Run Command. Use the feature to run a command that enables Windows Remote Management in case it is disabled. Next, run a command to open a Windows Remote Management inbound port. Next, run a command to enable PowerShell remoting. In the next task, you'll connect to an Azure VM by using the Windows Admin Center gateway running in Azure VM. Switch to the window displaying the Windows Admin Center gateway running on the Azure VM. Click Windows Admin Center. Add a connection to the Azure VM with the suffix VM0. Enter the information as shown on your screen. After successfully connecting to the VM, examine the Overview pane in Windows Admin Center. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Implementing and Configuring Virtualization in Windows Server. To navigate this interactive lab simulation, follow the prompts on the screen or use your forward and back arrow. In this lab, you'll complete the exercises listed on the screen. In this first exercise, you'll create and configure a virtual machine. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create a Hyper-V virtual switch. On Seattle Admin 1, in Server Manager, select Seattle Server 1 and use its context-sensitive menu to start Hyper-V Manager targeting that server. In Hyper-V Manager, use the Virtual Switch Manager to create a private virtual switch on Seattle Server 1. In the next task, you'll create a virtual hard disk. Click New. Select Hard. Use the new virtual hard disk. Select VHD. Select Differencing. Specify the virtual hard disk to use as the parent for the new differencing virtual hard disk. In the next task, you'll create a virtual machine. Click New. Use the New Virtual Machine wizard to create a new virtual hard disk on Seattle Server 1. Select the newly created virtual hard disk. Open the Settings window for Seattle VM1 and enable Dynamic Memory with the maximum RAM value of 4096 MB. In the next task, you'll manage virtual machines using Windows Admin Center. On Seattle Admin 1, start Windows PowerShell as an administrator. Run the commands as shown to download and install the latest version of Windows Admin Center. Start Microsoft Edge and connect to the local instance of Windows Admin Center. In Windows Admin Center, add a connection to seattleserver1.contoso.com and connect to it. In the Tools list, select Virtual Machines and review the Summary tab. Return to the Inventory tab. Select Seattle VM 1. Select Settings and create a new disk 5 GB in size. Use Windows Admin Center to start Seattle VM 1 and then scroll down to review the statistics for the running VM. Scroll up. Shut down the virtual machine. List, select Virtual Switches and identify the existing switch. This exercise is now complete. Click the screen to continue. In this next exercise, you'll install and configure containers. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install Docker on Windows Server. On Seattle Admin 1 in Windows Admin Center, while connected to seattleserver1.contoso.com, use the Tools menu to establish a PowerShell remoting session to that server. Run the commands as shown to force the use of TLS 1.2 and install the PowerShell Get module. When installation completes, run the command to restart Seattle Server 1. Click Connect to reconnect. Next, run the command as shown to install the Docker Microsoft Package Management Provider. Next, install the Docker Runtime. Restart Seattle Server 1. In this next task, you'll install and run a Windows container. Use the PowerShell tool again to establish a new PowerShell remoting session to Seattle Server 1. Run the command as shown to verify the installed version of Docker. Next, identify Docker images currently present on Seattle Server 1. Run the command as shown to download a nanoserver image containing an Internet Information Services, or IIS, installation. Run the command to verify that the Docker image has been successfully downloaded. Now, run the command to launch a container based on the downloaded image. Retrieve the IP address information of the container host. Switch to the Microsoft Edge window, open another tab, and go to the IP address of the container host. Verify that the browser displays the default. Run the command to list running containers. Next, run the command to stop the running container. Now, run the command to verify that the container has stopped. In the next task, you'll use Windows Admin Center to manage containers. In the Tools menu of seattleserver1.contoso.com, select Containers. In the Containers pane, browse through the Overview, Containers, Images, Networks, and Volumes tabs. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Deploying and Configuring Windows Server on Azure VMs. To navigate this interactive lab simulation, follow the prompts on the screen or use your forward and back arrows. In this lab, you'll complete the exercises listed on the screen. In this first exercise, you will author ARM templates for Azure VM deployment. In this first task, you'll connect to your Azure subscription and enable enhanced security of Microsoft Defender for Cloud. On Seattle Admin 1, start Microsoft Edge. In the Azure portal, browse to the Microsoft Defender for Cloud page. From the Microsoft Defender for Cloud Getting Started page, enable enhanced security of Microsoft Defender for Cloud and enable automatic Microsoft Defender for Cloud agent installation. In the next task, you'll generate an ARM template and parameters files by using the Azure portal. From the Azure portal, navigate to Virtual Machines. Follow the prompts to create a new Azure VM with the new resource group. Next, configure the disks for the virtual machine. Next, create a new virtual network for the virtual machine. In the Public IP drop-down menu, select None. Next to NNIC Network Security Group, also select None. Continue to the Management. Keep the defaults and click Review and Create. In the next task, you'll download the ARM template and parameters files from the Azure portal. From the Review and Create tab of the Create a Virtual Machine page, download the template for automation and copy it to appropriate lab files folder on the local disk. In the Azure portal, close the Template and Create a Virtual Machine pages. This exercise is now complete. Click the screen to continue. In this next exercise, you'll modify ARM templates to include VM extension-based configuration. Follow the prompts to complete the tasks in this exercise. In this first task, you'll review the ARM template and parameters files for Azure VM deployment. Open File Explorer. Extract the contents of the downloaded archive into the local folder. Open the template.json file in Notepad and review the contents. Keep the Notepad window open and open the parameters.json file in Notepad. Review the contents and then close this Notepad window. In this next task, you'll add an Azure VM extension section to the existing template. Return to the Notepad window displaying the contents of the template.json file. Scroll down to add the code as shown directly underneath the resources line. Close the file and when prompted, save. This exercise is now complete. Click the screen to continue. In this next exercise, you'll deploy Azure VMs running Windows Server by using ARM templates. Follow the prompts to complete the tasks in this exercise. In this first task, you'll deploy an Azure VM by using an ARM template. On Seattle Admin 1, in the Azure portal, browse to the Custom Deployment page. Select the option to build your own template in the editor. Load the template file and the parameter file into the Custom Deployment page. Configure the settings as shown, and then deploy the template. Verify that the deployment. Next task, you'll review results of the Azure VM deployment. In the Azure portal, go to Resource Group page. Review the list of its resources and then select the Azure VM. Verify that the custom script extension has been provisioned successfully. Browse back to the Resource Group page. Review its deployments. Review the Microsoft.template that was used to deploy it. This exercise is now complete. Click the screen to continue. In this next exercise, you'll configure administrative access to Azure VMs running Windows Server. Follow the prompts to complete the tasks in this exercise. In this first task, you'll verify the status of Azure Microsoft Defender for Cloud. In the Azure portal, browse to the Microsoft Defender for Cloud page. Scroll down and verify that the enhanced security features of Microsoft Defender for Cloud are enabled. First, select Environment Settings. Click Azure Pass. Click Enable All. Scroll down to review the Defender plans. Next, select Auto Provisioning. Close the pane. next task, you'll review the just-in-time VM access settings. Select Workload Protections. Scroll down to the Advanced Protection section. Click Just-in-Time VM Access. On the Just-in-Time VM Access page, review the Configured, Not Configured, and Unsupported tabs. This exercise is now complete. Click the screen to continue. In this next exercise, you'll configure Windows Server security in Azure VMs. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create and configure a network security group. In the Azure portal, navigate to Network Security Groups. Create a new network security as shown, leaving all other settings with their default values. Click Create. Next, select Inbound Security Rules. Add an inbound security rule to the newly created network security group as shown. In this next task, you'll configure inbound HTTP access to an Azure VM. In the Azure portal, navigate to the Azure VM and select Networking. Select the network interface attached to the Azure VM, and then associate it with the network security group you created in the previous task. Click Save. Next, click IP. Select the IP configuration of the network interface attached to the Azure VM and associate it with a new public IP address as shown. Click Save. Close the page. The public IP address of the network interface and then navigate to it in a new browser tab. Verify that the page displays a Hello World message from the VM. Next, try to establish a remote desktop connection to the same IP address. Verify that the connection attempt fails as close the remote desktop connection window and the browser tab. In this next task, you'll trigger reevaluation of the just-in-time status of an Azure VM. Navigate back to the Azure VM page. Scroll down the left pane and select Configuration. Click the button to enable just-in-time VM access. Click Open Microsoft Defender for Cloud. On the Just-in-Time VM Access page, verify that the entry representing the Azure VM appears on the Configured tab. In this next task, you'll connect to the Azure VM via just-in-time VM access. Click Connect, and then follow the prompts to request just-in-time VM access. When prompted for credentials, sign in with the local administrator account. Verify that you can successfully access the operating system running in the Azure VM via remote desktop, and then close the remote desktop session. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Implementing and Configuring Network Infrastructure Services in Windows Server. To navigate this interactive lab simulation, in this lab, you'll complete the exercises listed on the screen. In this first exercise, you will deploy and configure DHCP. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install the DHCP role. On Seattle Admin 1, start Microsoft Edge and connect to the local instance of Windows Admin Center. Add a connection to seattleserver1.contoso.com and connect to it as contoso/administrator. In the Tools list, use Roles and Features to install the DHCP server role on Seattle Server 1. You can click Notifications to see the installation progress. Refresh the page. In the Tools list, select DHCP and install the DHCP PowerShell tools. In this next task, you'll authorize the DHCP server. Open Server Manager. In Server Manager, click Complete DHCP Configuration, and then complete the DHCP Post-Install Configuration Wizard. You'll create a scope. Return to Windows Admin Center. While connected to seattleserver1.contoso.com, use the DHCP tool to create a new scope as shown. Scroll down. Return to Server Manager. Next, add the server named seattleserver1.contoso.com to the DHCP console. In the left pane, expand the server node until you reach the Scope Options folder. Select the folder. In the right pane, navigate to the Scope options and configure the settings as shown. Click OK. In this next task, you'll configure DHCP failover. Select the IPv4 node of the DHCP server. In the right pane, navigate to the Configure Failover wizard. Follow the steps to configure failover of the scope to Seattle Domain Controller 1.contoso.com. Next, select DHCP and follow the prompts to add the Seattle Domain Controller 1.contoso server to the console. Expand Seattle Domain Controller 1. Verify that Follow the prompts to configure failover of the second scope using the settings of the existing failover relationship. In this next task, you'll verify DHCP functionality. On Seattle Admin 1, navigate to Windows Settings. Navigate to the Network and Sharing Center. In the Ethernet properties, change the IP configuration from statically to dynamically assigned. Click Details. Examine the resulting IP configuration and verify that the DHCP lease was obtained from Seattle Server 1. Return to the DHCP management. Verify that both DHCP servers list the lease for Seattle Admin 1 in the scope. Next, follow the prompts to stop the DHCP service on Seattle Server 1. Return to Control Panel and force renewal of the lease by disabling and re-enabling the Ethernet network connection on Seattle Admin 1. Verify that the same DHCP lease is obtained from Seattle Domain Controller 1. In the Ethernet properties, reset the IP configuration from dynamically to statically assigned. This exercise is now complete. Click Close to continue. In this next exercise, you'll deploy and configure DNS. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install the DNS role. On Seattle Admin 1, open Windows Admin Center. In the Tools list, use Roles and Features to install the DNS Server role on Seattle Server 1. Click Notifications to see the installation progress. In the Tools list, select DNS and install the DNS PowerShell tools. In this next task, you'll create a DNS zone. Follow the prompts to create a new DNS zone. Select the newly created. Next, use the DNS tool to create a new DNS record in the zone. The record created successfully. Next, open Windows PowerShell. Run the command as shown to verify that the newly created record resolves properly. In this next task, you'll configure forwarding. Return to Server Manager. From the Tools menu, open the DNS Manager console. When prompted, connect to Seattle Server 1. In the Server Properties, on the Forwarders tab, specify the IP address of the forwarder. In this next task, you'll configure conditional forwarding. Follow the prompts to create a new conditional forwarder for contoso.com that forwards requests to Seattle Domain Controller 1. Next, open Windows PowerShell and run a command to verify that the conditional forwarder is operational. In this next task, you'll configure DNS policies. Return to Windows Admin Center, which is still connected to Seattle Server 1. Use PowerShell to establish a PowerShell remoting session. Run the commands as shown. The first command creates a head office subnet. The next command creates a zone scope for head office. The next command creates a new resource record for the head office scope. The next command creates a new policy that links the head office subnet and the zone scope. In the next task, you'll verify DNS policy functionality. Open Windows PowerShell. Run ipconfig to verify that Seattle Admin 1 is on the head office subnet. Next, run the command as shown to test the DNS policy. Return to Ethernet properties and change the IP address assigned to Seattle Admin 1 to an IP address that is not within the IP address range of the head office subnet. Return to Windows PowerShell. Run the command as shown to test the DNS policy. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Implementing Hybrid Networking Infrastructure. To navigate this interactive lab simulation, follow the prompts on. In this lab, you'll complete the exercises listed on the screen. In this first exercise, you'll implement virtual network routing in Azure. Follow the prompts to complete the tasks in this exercise. In this first task, you'll provision core infrastructure resources. You will deploy 3 virtual machines into the same Azure region, but into separate virtual networks. The first virtual network will serve as a hub, while the other two will form spokes. On Seattle Admin 1, browse to the Azure portal where you're already signed in. Open a PowerShell session in the Cloud Shell pane. Upload the resource group template and template parameters JSON files into the Cloud Shell home directory. From the Cloud Shell pane, run the commands as shown to create the first resource group that will be hosting the lab environment. Next, run the following command to create 3 virtual networks with Azure VMs in them by using the template and parameter files you uploaded. Next, run the commands as shown to install the Network Watcher extension on the Azure VMs deployed in the previous step. In this next task, you'll configure the hub and spoke network topology by peering the virtual networks you deployed in the previous tasks. Open another tab to the Azure portal. Browse to the Virtual Networks page. Select the first virtual. Follow the prompts to create a peering to the second virtual network. Repeat the peering steps to add a peering between the first and third virtual network. In this next task, you'll test transitivity of virtual network peering by using Network Watcher. Browse to the Network Watcher page. Click Connection Troubleshoot. Follow the prompts to initiate a check. Scroll down to see the results. Verify that the status is. Follow the prompts to initiate a check for a different peering. Scroll down to see the results. Verify that the status is reachable. Review the network path and note that the connection was direct, with no intermediate hops in between the VMs. Refresh the page. Follow the prompts to initiate a check for a third peering, this time between the 2 spoke virtual networks. Scroll down to see the results. Note that the status is unreachable. In this next task, you'll configure routing between the two spoke virtual networks in the hub and spoke topology. Navigate back to the Virtual Machines page. Select the virtual machine with the suffix VM0. Click Networking. Click the Network Interface link and then open IP Configurations. Enable IP forwarding. Save the change and close the page. Now you need to configure the operating system of the virtual machine to support routing. Scroll down and select Run Command. From the list of operations, select Run PowerShell script. Enter and run the script to install the Remote Access Windows Server role. Next, install the Routing Role service. Now you need to create and configure user-defined routes on the spoke virtual networks. In the Azure portal, browse to Route Tables. Create a route table with the settings as shown. Click Review and Create, and then click Create. Click Go to Resource. Click Routes. Add a route as shown on your screen. Next, click Subnet. Associate the route table with the subnet on VNet 1 as shown. Browse back to the Route Tables page and create another route table with the settings as shown. Click Go to Resource. Click Routes. Add a route as shown on your screen. Next, click Subnets and associate the route table with the subnet on VNet 2 as shown. Navigate back to the Network Watcher Connection Troubleshoot page. Follow the prompts to initiate a connectivity check. down and verify that the status is reachable. This exercise is now complete. Click the screen to continue. In this next exercise, you'll implement DNS name resolution in Azure. Follow the prompts to complete the tasks in this exercise. In this first task, you'll configure Azure Private DNS Name Resolution. On Seattle Admin 1, browse to the Private DNS Zones page in the Azure portal. Create a private DNS zone with the settings as shown. Click Go to add a virtual network link to the first virtual network you created in the previous exercise as shown. Next, create virtual network links with auto-registration enabled for VNet 1 and VNet 2 respectively. Next, click Over. Review the listings of DNS record sets and verify that the A records of all 3 virtual machines appear in the list as auto-registered. In this next task, you will validate Azure Private DNS Name Resolution. Return to the Network Watcher Connection Troubleshoot page. Follow the prompts to initiate a check. Scroll down to see the results. Verify that the status is reachable. In this next task, you will configure external DNS name resolution by using Azure Public DNS Zones. Navigate to the DNS Zones page. Create a DNS zone with the settings as shown. Click Go to Resource. Add a record set with the settings as shown. On the DNS zone page, copy the full name of name server 1 for use in the next task. In this next task, you will validate Azure Public DNS Name Resolution. Open Windows PowerShell. Run the command as shown to test the external name resolution of the www DNS record set in the newly created DNS zone. Verify that the output of the command includes the public IP address. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Implementing Storage Solutions in Windows Server. To navigate this interactive lab simulation, follow the prompts on the screen or use your forward and back arrows. In this lab, you will complete the exercises listed on the screen. In this first exercise, you will implement the data deduplication service. Follow the prompts to complete the tasks in this exercise. In this first task, you'll install the data deduplication role service. On Seattle Admin 1, in Server Manager, click the Manage menu and select Add Roles and Features to get started. Proceed through the wizard and install the data deduplication role service on Seattle Server 3. Select the roles as shown. Close the wizard. Next, open File Explorer. From the local disk, share the Lab Files folder with the Users group and grant read permissions. Switch to the Seattle Server 3 console session. Sign in as an administrator. Start a PowerShell session. Run the commands as shown to create a volume formatted with REFS and with the drive letter M assigned to it. Next, run the commands as shown to copy a script from Seattle Admin 1 that creates sample files to be deduplicated, execute the script, and identify the outcome. In this next task, you'll enable and configure data deduplication. In Server Manager, use the File and Storage Services interface to display disks on Seattle Server 3. Enable data deduplication on Seattle Server 3 on disk number 1 on the M volume, with the settings as shown. Click OK. In this next task, you'll test data deduplication. Start Microsoft Edge and connect to the local instance of Windows Admin Center. Add a connection to seattleserver3.contoso.com and connect to it with administrator credentials. In the Tools list, use the PowerShell tool to run a command that triggers deduplication. Return to the Seattle Server 3 console session. At the Windows PowerShell prompt, run the command as shown to identify the available space on the volume being deduplicated. Allow the deduplication. Return in Windows Admin Center, connected to seattleserver3.contoso.com, use the PowerShell tool to run the following commands that identify the status of the deduplication job. Switch. Refresh the Disks pane. Display the properties of the M volume. Review the values for deduplication rate and deduplication savings. Click OK. In this next exercise, you'll configure. In this first task, you'll install iSCSI and configure targets. On Seattle Admin 1, in the Windows PowerShell console, establish a PowerShell remoting session to Seattle Server 3. Run the command as shown to install an iSCSI target on Seattle Server 3. Run the commands as shown to create a new volume formatted with REFS on disk 2. Next, run the commands as shown to create a new volume formatted with REFS on disk 3. Next, run the commands as shown to configure Windows Defender Firewall with advanced security rules that allow iSCSI traffic. Now run the commands as shown to display the drive letters assigned to the newly created volumes. In this next task, you'll connect to and configure iSCSI targets. On Seattle Admin 1, open Server Manager. Navigate to the Disks pane and refresh it to display the disk configuration of Seattle Domain Controller 1. Note that it only contains the boot and system volume drive C. From the Tasks menu, select New iSCSI Virtual Disk. Use the wizard to create an iSCSI virtual disk with the settings as shown. Now create a second iSCSI virtual disk with the settings as shown. Switch to the Seattle Domain Controller 1 console session. Sign in. Start a Windows PowerShell session, and then run the commands as shown to start the iSCSI Initiator service and display the iSCSI Initiator configuration. Use the iSCSI Initiator. In this next task, you'll verify iSCSI disk configuration. On Seattle Admin 1 in Server Manager, browse to the Disks pane and refresh its view. Review the Seattle Domain Controller 1 disk configuration and verify that it includes two 5 GB disks with an offline status and the iSCSI bus type. Switch to the Seattle Domain Controller 1 console session. Run the command to display the disk configuration. Both disks are present and healthy, but offline. To use them, you need to initialize and format them. Run the commands as shown to create a volume formatted with REFS with the drive letter E. Repeat the previous commands to create a new drive formatted with REFS, but this time, use the disk number 2 and the drive letter F. Review the Seattle Domain Controller 1 disk configuration and verify that both drives are now online. In this next task, you'll revert disk configuration. Navigate to Windows PowerShell. Run the commands as shown to reset disks on Seattle Server 3 to their original state. In this next exercise, you'll configure redundant storage spaces. Follow the prompts to complete the tasks in this exercise. In this task, you'll create a storage pool. On Seattle Admin 1, click File and Storage Services. Select Disks and scroll down the pane. Under Seattle Server 3, set the status of disks 1 through 4 to Online. On the Tasks menu, select New Storage Pool. Use the wizard to create a new storage pool named SP1, targeting storage configuration of Seattle Server 3, consisting of the 3 disks that are 127 GB in size. In this next task, you'll create a volume based on a 3-way mirrored disk. Use the newly created storage pool SP1 to create a virtual disk named 3Mirror that uses the mirror storage layout, thin provisioning, and has the size of 25 GB. Use the newly provisioned virtual disk to create an REFS volume named Test Data. Set its size to all available disk space and assign it to drive letter T. In this next task, you'll manage a volume in File Explorer. Switch to the Windows PowerShell window with the PowerShell remoting session to Seattle Server 3. Start a PowerShell remoting session to Seattle Server 3. Run the command as shown to enable all of the file and printer sharing rules of Windows Defender Firewall with advanced security. Open File Explorer. Follow the prompts to navigate to the Seattle Server 3 network share. Create a folder named Test Data, and then within the folder, create a document named testdocument.txt. In this next task, you'll disconnect a disk from the storage pool and verify volume availability. Return to Server Manager. Select Storage Pools. Add the remaining available disk attached to Seattle Server 3 to the storage pool SP1. Ensure the disk uses automatic allocation. Next, remove one of the first 3 disks allocated to the SP1 pool. Return to File Explorer to verify that testdocument.txt is still available. In this next task, you'll add a disk to the storage pool and verify volume availability. Return to Server Manager. Rescan the SP1 storage pool. Add back the disk you removed in the previous task and ensure that it uses automatic allocation. Use File Explorer to verify that test.document.txt is still available. In this next task, you'll revert disk configuration. Return to Windows PowerShell. Run the commands as shown to reset disks on Seattle Server 3 to their original state. This exercise is now complete. Click the screen to continue. In this next exercise, you'll implement Storage Spaces Direct. Follow the prompts to complete the tasks in this exercise. In this first task, you'll prepare for installation of Storage Spaces Direct. Verify that Seattle Server 1, Seattle Server 2, and Seattle Server 3 have the manageability status of Online Performance Counters Not Started. Next, click File and Storage Services and open the Disks pane. Bring online all of the disks attached to Seattle Server 1, Seattle Server 2, and Seattle Server 3. Start the Windows PowerShell ISE. Open Implement Storage Spaces Direct in its script pane. Run the first command in Step 1 to install the file server role and failover clustering feature on Seattle Server 1, Seattle Server 2, and Seattle Server 3. Run the second command in Step 1 to restart Seattle Server 1, Seattle Server 2, and Seattle Server 3. Run the third command in Step 1 to install the Failover Cluster Manager tool on Seattle Admin 1. In this next task, you'll create and validate the failover cluster. Switch to Server Manager. From the Tools menu, start Failover Cluster Manager. Switch to the Windows PowerShell ISE. Run the Step 2 command to invoke cluster validation tests. Scroll down. Run the Step 3 command to create a cluster. When the command completes, switch to Failover Cluster Manager and add the newly created cluster named s2dcluster.contoso.com. In this next task, you'll enable Storage Spaces Direct. Switch to the Windows PowerShell ISE. Run the Step 4 command to enable Storage Spaces Direct on the newly installed cluster. Next, run the Step 5 command to create the storage pool named S2D Storage Pool. Switch to Failover Cluster Manager and verify that the cluster contains the storage pool named Cluster Pool 1. Switch to the Windows PowerShell ISE and run the Step 6 command to create virtual disks. Switch to Failover Cluster Manager and verify that the cluster virtual disk. In this next task, you'll create a storage pool, a virtual disk, and a share. Return to the Windows PowerShell ISE. Scroll down. Run the Step 7 command to create the S2D SOFS role. Switch to Failover Cluster Manager and verify that the S2D SOFS object appears in the Roles pane. Switch to the Windows PowerShell ISE and run all three commands in Step 8 to create the VM01 share. Switch to Failover Cluster Manager and select the S2D SOFS role. Verify that the VM01 share appears in the Shares tab. In this next task, you'll verify Storage Spaces Direct functionality. In File Explorer, navigate to the VM01 share and create a folder named VM folder. Switch to the Windows. Run the command as shown to shut down Seattle Server 3. Switch to Server Manager, refresh the All Servers view, and verify that Seattle Server 3 is no longer accessible. Switch to Failover Cluster Manager and review the Cluster Virtual Disk CSV information in the Disks node. Switch to the Microsoft Edge window displaying Windows Admin Center. Add a connection to the S2D cluster.contoso.com cluster. Connect to the newly created cluster. On the cluster's dashboard pane, identify the alert indicating that Seattle Server 3 is not reachable. The server can be restarted from the console session. Verify that the alert is removed. This interactive lab simulation is now complete. Welcome to this interactive lab simulation for the lab Implementing Azure File Sync. To navigate this interactive lab simulation, follow the prompts on the screen or use your forward and in this lab, you'll complete the exercises listed on the screen. In this first exercise, in this first task, you'll deploy DFS. On Seattle Admin 1, open Windows PowerShell. Run the command as shown to install DFS management tools. Open File Explorer and locate the folder containing the DFS deployment script. Open the script in a new Windows PowerShell ISE window. Review the script and then execute it to create a sample DFS namespace and a DFS replication group. In this next task, you'll test DFS deployment. Start the DFS Management Console. Add it to both the contoso.com root namespace and the branch 1 replication group you created in the previous task. In the left pane, verify that the contoso.com root namespace's data folder has targets on Seattle Server 1 and Seattle Server 2. Note the folders configured as the targets. Verify that the branch 1 replication group has two members, Seattle Server 1 and Seattle Server 2. Open File Explorer and connect to Seattle Server 1 data. Open a second instance of File Explorer and connect to Seattle Server 2 data. Create a new file in Seattle Server 2 data, and then confirm that the file replicates to Seattle Server 1 data. This confirms that DFS replication is working. This exercise is now complete. Click the screen to continue. In this next exercise, you'll create and configure a sync group. Follow the prompts to complete the tasks in this exercise. In this first task, you'll create an Azure file share. Open the Azure portal and navigate to Storage Accounts. Create an Azure storage account with locally redundant storage, LRS, in a new resource group, with the settings as shown. Click Go to Resource. In the storage account, create a file share named Share1. In this next task, you'll use an Azure file share. Click Share1. Upload the file1.txt file. Close the pane. In the Azure portal, create a snapshot of Share1. Next, click Overview. Mount Share1 as the drive Z by using the connection script that the Azure portal provides. In File Explorer, on the mounted drive, open File 1, enter a line of text, and then save the file. In File Explorer, open the file's properties. Use previous versions to restore the previous version of File 1. Open File 1. Close the file. In this next task, you'll deploy the Storage Sync service and a File Sync group. From the Azure portal, navigate to Azure File Sync. Create an Azure File Sync resource named File Sync 1. Click Go to Resource. Create a sync group named Sync 1 in the File Sync 1 Storage Sync service. Click Registered Servers. Verify that no server is currently registered with File Sync 1. This exercise is now complete. Click the screen to continue. In this next exercise, you'll replace DFS replication with File Sync-based replication. Follow the prompts to complete the tasks in this exercise. In this first task, you'll add Seattle Server 1 as a server endpoint. On Seattle Admin 1, download the Azure File Sync agent for Windows Server 2022 and then save it to the folder for this lab on the local disk. Open Install File Sync Server Core in the Windows PowerShell ISE. Review the script and then execute it to install the File Sync agent on Seattle Server 1. When prompted, authenticate to your Azure subscription. Return to the Azure portal. Refresh the registered servers in the File Sync 1 Storage Sync service, and notice that seattleserver1.contoso.com is now registered. In File Explorer, open Seattle Server 1 Data and refresh the page. Notice that the folder doesn't contain the File 1 text file. Return to the Azure portal. Click Sync Groups. Select Sync 1. Add S-Data on seattleserver1.contoso.com as a server endpoint to Sync 1. Switch to File Explorer and verify that File 1 is available. In this next task, you'll register Seattle Server 2 with File Sync. Return to the Windows PowerShell ISE. In the Install File Sync Server Core script, replace Seattle Server 1 with Seattle Server 2, and then run the script. When prompted, authenticate to your Azure subscription. Close the pane. Select Registered Servers and verify that both servers are registered with the FileSync1 storage sync service. In this next task, you'll remove DFS replication and add Seattle Server 2 as a server endpoint. Switch to DFS Management. Delete the Branch 1 replication group. Return to the Azure portal and select Sync Groups. Select Sync 1. Add sdata on seattleserver2.contoso.com as a server endpoint to Sync 1. This exercise is now complete. Click the screen to continue. In this next exercise, you'll verify replication and enable cloud tiering. Follow the prompts to complete the tasks in this exercise. In this first task, you'll verify file sync. Open File Explorer to display the content of Seattle Server 1 data. Create a file with an arbitrary name. Verify that shortly afterwards the file with the same name appears in the Seattle Server 2 data folder. In its next task, you'll enable cloud tiering. Return to the Azure portal. From the Sync1 sync group, enable cloud tiering for the Seattle Server 2.contoso.com endpoint as shown. Switch to the Windows PowerShell. Run the commands as shown to trigger tiering. Switch to File Explorer on the Seattle Server 2 data share. Open the folder's context menu and add the Attributes column. Identify files with the attributes L, M, and O, which indicate that the tiering took place. This exercise is now complete. Click the screen to continue. In this next exercise, you'll troubleshoot replication issues. Follow the prompts to complete the tasks in this exercise. In this first task, you'll monitor file sync replication. On Seattle Admin 1, use File Explorer to navigate to the local Windows folder. Copy the INF folder to Seattle Server 2 data. The folder will sync to the cloud endpoint, causing sync traffic. Open the Azure portal to the Sync1 sync group in the FileSync1 storage sync service. In the Server Endpoints section, verify health of both endpoints. Select the Seattle Server 2.contoso.com endpoint, and then, in the Server Endpoint Properties pane, review sync activity. Select the Files Synced graph and explore how you can customize the graph by using a filter. Open File Explorer and verify that the INF folder is syncing to drive Z. In the Azure portal, verify that the INF synced traffic is reflected in the files synced and bytes synced graphs. The INF folder has more than 800 files, and its size is more than 40 megabytes. In this next task, you'll test replication conflict resolution. Position the File Explorer windows displaying the content of Seattle Server 1 data and Seattle Server 2 data side by side. In each File Explorer window, create a file named demo.txt. Open the first demo file and add some arbitrary text. Click Save. Open the second demo file and add a different arbitrary text. Click Save. In the Seattle Server 1 File Explorer window, review the content of the demo file. The demo content says text2, so the more recent version of the file created on Seattle Server 2 is the one that got synced. Next, review the demo Seattle Server 1 file. This file says text. In this next exercise, you'll clean up the Azure subscription. Follow the prompts to complete the task in this exercise. In this first and only task, you'll delete Azure resources that you created. Navigate back to the File Sync 1 Storage Sync Service page. Click Registered Servers. Remove each server by unregistering it. Next, delete the Sync1 sync group. Next, navigate to the File Sync 1 Storage Sync Service and delete it. Also, delete the Azure Storage account. Finally, create the resource group. This interactive lab simulation is now complete.